Welcome to Manifested Publishers.
Hello learners, welcome to Manifested online classes. My name is Mwaneki. We are continuing with Chemistry Form 3 and our topic is gas laws. In the previous lessons, we discussed Charles Law, where we said that Charles Law states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature at constant pressure. Remember again, he said it's absolute. Therefore, all the calculations involving Charles' law should the temperature be converted to Kelvin from degrees Celsius. And we also did the conversion of degrees Celsius to Kelvin and Kelvin to degrees Celsius. And we say that if you want to convert temperature from degrees Celsius to Kelvin, you just add 273. For example, if you are given 0 degrees Celsius, then if you want to convert this temperature to Kelvin, you just add 273, so it will be 0 plus 273, and it will give you 273 Kelvin. If you have 100 degrees Celsius, and if you want to convert this temperature to Kelvin, then it will be 100, you add 273, and then you'll get 373 Kelvin. Therefore, anytime you want to convert temperature from degrees Celsius to Kelvin, you just add 273. And we also say that if you want to convert temperature from Kelvin to degrees Celsius, you subtract 273. Example, if you have 70, let's say you have 0 Kelvin, you want to convert this temperature to degrees Celsius, will be 0, subtract 273, which will give you 273 degrees Celsius. It will be negative 273 degrees Celsius. 0 minus 273 gives you negative 273 degrees Celsius. Again, if you have 273 Kelvin, you want to convert this temperature to degrees Celsius, again it will be 273. You subtract 273, you get as 0 degrees Celsius. Therefore, 273 Kelvin and 0 degrees Celsius, it is the same amount of temperature, only that one is in degrees Celsius and the other one is in Kelvin. That is what we learned in the previous lesson. In this lesson, the objective is that by the end of this lesson, you should be able to do worked examples or some examples on Charles' law. Therefore, in this lesson, I want us to do examples. I want to give you one example and guide you through on how you can be able to do calculations involving Charles' law. First one, that is our first example. It says a gas occupies 450 centimeters cubed at 27 degrees Celsius. What volume would the gas occupy at 177 degrees Celsius if pressure remains constant? Therefore, the solution to this question would be first of all, you should remember the formula we gave yesterday about the Charles Law, and we said that in Charles Law, this is the relationship we use, that V1 over T1 is equals to V2 divided by T2. So V1 over T1 is equals to V2 over T2, where V1, this is the initial volume, V2 is a final volume, T1 is the initial temperature, T2 is a final temperature. Therefore, in this calculation, you can now be able to isolate the V1, T1, T2, V2 like that. Therefore, in this calculation of V1, a gas occupies 450 centimeters cubed at 27 degrees Celsius. So the V1 will be 450 centimeters cubed. Then T1 is now 27 degrees Celsius. Then what volume would the gas occupy at 177 degrees Celsius? Therefore, we have T2 as 177 degrees Celsius. V2 we don't have, and that is what we are looking for. Therefore, we don't have V2. And remember again, he said that all the calculations involving Charles' law, that temperature should always be converted to Kelvin. And therefore, our T1 will be 27 plus 273 to make them Kelvin, and the T2 will be 177 plus 273 to make them Kelvin also. If you have a calculator, then you can calculate that 27, you add 273, this gives you 300 Kelvin. Then 177, you add 273, this gives you 450 Kelvin. You should not forget to convert the temperature into Kelvin at all times. Therefore, now once you have the values, then you just need to substitute from the formula that from the formula, V1 is 450 divided by T1, which is now 300 Kelvin. Don't use 27, but 300 Kelvin. So it's 300 is equals to V2. We don't have V2. Therefore, it's V2 divided by T2. And our T2 is 450 Kelvin. 450. And therefore, to be able to get the V2, we just need to cross multiply. Therefore, V2 will be given by 450. You multiply by 450. Then you divide by 300. This will give you 450 multiplied by 450. This is divided again by 300. gives you 675 centimeters cubed. You should not forget the units because that is the volume, and therefore the volume at 177 degrees Celsius is 675 cubic centimeters. Volume at 177 will be 675 cubic centimeters from your question, because that is what is asked in this question. I hope you understand that very well. Remember, I've said that the formula we are using to calculate Charles law is V1 divided by T1 is equals to V2 divided by T2. Then we need now from the question to isolate which is V1, which is V2, which is T1, which is T2. And then from the question now you'll be able to see what has been left out, and that is now what you are looking for in the course of your calculation. We have seen in this question that our V1 is 450 centimeters cubed, our T1 is 27 degrees Celsius, and we have seen that all the calculations involving Charles law, then you must convert temperature in degrees Celsius to Kelvin, and that's why we have handed 273, then you have gotten 300 Kelvin. Then our T2, which is now second temperature, then this is 177 degrees Celsius. We have added 273 to convert them to Kelvin. You have gotten 450. And we don't have V2, so V2 is now what we are looking for. Then here we just substitute what we have and what we don't have, so that we are now left with V2, which we are looking for. Then to get the V2, you just cross multiply. You cross multiply this, so it will be 450 times 450, you divide by 300, and that is now what we have seen here. So it's V2, then V2 is now 675 cubic centimeters. I hope you will get that so well. I want to give you the second example. And the second example is this. Therefore, that is the question. Question is, at what temperature of 57 degrees Celsius, nitrogen, at a temperature of 57 degrees Celsius, nitrogen gas occupies a volume of 750 centimeters cubed. At what temperature will the gas occupy 100 centimeters cubed? Then you're told, express your answer in degrees Celsius. Therefore, this is how we go about it. The solution to this will be, we have the formula. The formula, you know that it's V1 over T1 is equals to V2 divided by T2. V1 is 750. T1 is 57 degrees Celsius. V2 is 100 centimeters cubed. And T2 we don't have, and that is what we are looking for. Therefore, again, you need to remember to convert the temperature from degrees Celsius to Kelvin. And therefore, this will earn 273. Then this will give you, that is 57. You earned 273. This gives you 330. 330 Kelvin. Don't forget to convert that. And therefore, we just need to substitute from our formula. V1 is 750. T1 is 330. Then V2 is 100. And T2 we don't have, and that is what we are looking for. Therefore, to get T2, we just cross multiply. This will be given by 330 times 100 and divide by 750. So 330 times this 100 divided by 750. And this will be to be 33,000 divided by 750. Get this as this gives you 44. Is our T2. And therefore, 44 is now in Kelvin because we had already converted our T1 into Kelvin. And therefore, T2 again is also in Kelvin. Again, remember, you're supposed to express your answer in degrees Celsius. And therefore, you have to convert this 44 Kelvin into degrees Celsius. And we say that you convert temperature from Kelvin to degrees Celsius we subtract 273. And therefore, this will be, or T2 will be 44, we subtract 273. And this will give you negative 229 degrees Celsius. Therefore, our T2 is negative 229 degrees Celsius. That is the temperature in degrees Celsius. So you just need to remember everything you have done. Don't forget the formula V1 divided by T1 is equals to V2 divided by T2. And from there you can now be able to get to isolate the V1, T1, T2, V2 from the question. Now, whichever will not be given, that is now what you are calculating for. And again, don't forget to convert temperature from degrees Celsius to Kelvin in the course of your calculation, because you are talking about absolute temperature when it comes to Charles' law. And that is our lesson today. But before I end this lesson, I will leave you with this assignment. I'll give you two questions which I'm going to do. That is the assignment, just two questions. The first one, a gas occupies 200 centimeters cubed at 0 degrees Celsius and 740 millimeters of mercury pressure. What volume will it occupy at 47 degrees Celsius at the same pressure? Second, is a balloon contains 100 centimeters cubed of air at 25 degrees Celsius. The balloon was put outside in the sun where the temperature was 40 degrees Celsius. Calculate the new volume of the air. Attempt those two questions, do them right. Always remember to convert the temperature into Kelvin. Then the next lesson, we'll go through those questions to see whether you've done them in the correct way. Thank you for being part of the lesson. God bless you. Thank you.